What's going on, Algebra Bros? In this video, we're going to analyze the graph of a rational function by finding its domain and range, the intercepts, if any, horizontal asymptotes, if any, vertical asymptotes, and oblique asymptotes, if any. And of course, we are provided the rational function's graph, not necessarily its equation. So let's go ahead and get started with that. Okay, so part A, what is the domain? Well, I want to point out that there is a vertical asymptote here, and the vertical asymptote appears to be at x equals -2. So underneath this vertical dashed line, I'm going to write x equals -2. That would be the equation for the vertical asymptote. It's also an indication of an x value that we should exclude from the domain. In particular, x equals -2, while it's good for writing the equation of a vertical asymptote, -2 is actually bad for the domain of the rational function. Alright, so keep in mind that division by 0 is what creates these vertical asymptotes. And since that's the only vertical asymptote and the graph, the blue pieces of the graph appear to be fully connected with no holes, we can assume that our domain is the set of all x such that x cannot equal -2. So we would select option A. There is a domain restriction here that's -2, and that's it for part A. Well, actually, nope, we need the range as well. Alright, so the range is going to be very similar with regard to how you can use asymptotes. So with the range, you want to take a look at any horizontal asymptotes. There appears to be a horizontal asymptote which crosses the y-axis at y equals -1. And with horizontal asymptotes, they affect what the outsides or the ends of the graph will be doing as x goes to positive infinity or negative infinity. So if we keep track of the blue part of the graph that's kind of in the upper right-hand corner of these asymptotes, and we look at what's happening to that part of the graph as x goes to infinity, we get an end of the graph that appears to get really close to y equals -1, but never crosses or touches it. And going on the opposite side, we get a piece of the graph underneath the horizontal asymptote approaching it, but appearing to never cross or touch it. So in terms of range, it appears that y equals -1, which is the equation for a horizontal asymptote. Y equals -1 is not being used as an element of the range. So we would have to exclude -1 from the range. So where it says here, what is the range? We'll select option A. And we'll say it's the set of all y such that y does not equal -1. So again, y equals 1 as a regular equation is good for identifying the equation for the horizontal asymptote. But in this case, -1 is not being used as a y value on the graph, so we're going to exclude it from the range. Part B wants us to find the intercepts, so that includes both the x and y intercepts. It appears as though there's just one of each, and that would be at the origin, 0, 0. There's nowhere else where I'm seeing the graph crossing the y-axis nor the x-axis. So the x-intercept is at x equals 0, the y-intercept is at y equals 0. So for part B, we'll select option capital A. We'll write x equals 0. And then we'll select option capital A again and write y equals 0 for the y-intercept. For part C, it wants us to find the horizontal asymptote, and we actually already did that. We saw that the horizontal asymptote crossed the y-axis at y equals -1, so we'd select option capital A and type in -1. There is one vertical asymptote, and that was at, I believe, sorry, that's my cat Luigi, x equals -2. So we'd select option capital A and type in -2. And then for oblique asymptotes, these would show up as These can show up as a couple of different things. One, it could show up as sort of like a slanted line, or it could show up as, well, that slanted line would be dashed, much like the other asymptotes, or it could show up as like a dashed curve. And if you look at our graph, there's none of that going on. We have asymptotes that are both vertical and horizontal, and there's no other asymptote. So for that reason, there's actually no oblique asymptote. So sorry for all this up and down, but at the very end of this problem, we would select option B. There are no oblique asymptotes, only vertical and horizontal. And that's where the pain and torture, fun and excitement ends for this video. Thanks for watching, and I'll see you in the next one.